Hi everyone, welcome to Study with Akshay and this is Akshay. In this video, we are going to deal with the exercise questions of 1A, exercise 1A, that is our first chapter. And this is a continuation of it, that is set 4. So over here, in the previous video, we had dealt with 18th question. We are going to continue with the 19th one. Before getting started, if you have not subscribed to my channel, please do subscribe and hit on the bell icon to get regular notifications. Let's not waste much time. Let's get started. What do you understand by term couple? State its effect. Give two examples in our daily life where couple is applied to turn a body. So yes. So couple is basically an interesting topic. So two equal and opposite parallel forces not acting along the same line or a straight line form a couple. So this is basically what do you understand by the term couple? This is with respect to the first question. Here we gained 1 mark. State its effect. A couple is always needed to produce the rotation. For example, turning a key in a lock and turning a steering wheel. So this is an example and this part is with an effect. So it is used to produce rotation in a body, that is the effect of couple, and examples are turning of a key in a lock and turning a steering wheel. So here we get another 2 marks. So totally this is a 3 marked question. Let's move ahead further. Define moment of couple. Write its SI units. Okay, first let's define it. The moment of couple is equal to the product of either forces and the perpendicular distance between the line of action between two forces or between both the forces. You can take any other thing. All the things means the same. Okay, so basically the key terms are equal to the product of either forces and the perpendicular distance between line of action of force of both the forces or line of action between two forces. Okay, this is meant by moment of couple. Here we gained 1 mark, or if this complete question is for 1 mark, then we will be gaining just half a mark. Write a SI unit. SI unit is Newton meter. Okay, just like a moment of force, here also it is a Newton meter, not joules. Okay. So I have already told you why it is not joules in the previous videos. You can go back to the playlist, watch those videos and then come back to this question so that the concepts will become more clear. Hope you have make a note of this. Yes, let's move ahead further with the next one. Prove that moment of couple is equal to force into couple arm. So these questions are not basically asked, but for a safer side, let's remember this, how to prove. So this is a diagram. We have a diagram over here, right? So for this diagram, what we can do. So this is a complete lengthy explanation. Since it is a lengthy, I can make it a bit short for you at A and B with respect to this diagram. Okay, I repeat, this is with respect to this diagram. Don't name it as P and Q and write at A and B. In that case, they won't give you marks. Okay, it will be completely wrong. Two equal and opposite forces, each of magnitude F, are applied. You can see F magnitude. These are two forces. So this makes the bar, okay, meter rule or any bar rotates in anti-clockwise direction. Since force is applied, it moves like this. This side also force is applied, it moves. It makes us move in an anti-clockwise direction. Just write in your own words by understanding the concept. Okay, it is not a compulsory that you have to follow the same sequence. Okay, it would be better if you follow it, but it's not a compulsory one. And the perpendicular distance between the two forces is A and B. AB. AB is the perpendicular distance. We can see over here the distance, it is marked as D, which is called a couple arm. Okay, this I have taught you while introducing the couple concept itself. Moment of force at end A is F into OA, that is anti-clockwise movement. F into OA. This is the moment of force over here. Moment of forces B will be F into OB. Both are in anti-clockwise direction. So OA plus OB is nothing but AB, right? F into AB. Then we will take F is common over here. With this equation, we are taking F as common. OA plus OB, that is nothing but AB. Hope you are understanding. So over here, AB has been abbreviated by the magnitude as D. D is the magnitude of AB. So F into D, that is anti-clockwise. So either forces, F is the either forces, and D is the perpendicular distance between the two forces, or the couple arm. Thus, moment of force is equal to force into couple arm. Hope you have copied this and hope you have understood this. If you have any doubts, you can post in the comments section or you can mail me. You all are aware of the mail ID, right? Yes, I will be repeating it at the end also. Or you can pause the video, make a note of it, and then you can play the video. Let's move ahead with the next question. What do you mean by equilibrium of a body? Quite an interesting concept, right? Equilibrium is also. Okay. When a number of forces acting on a body produces no change in its state of rest or motion, the body is said to be in equilibrium. So for an example, you are moving a ball and the ball is not moving. In that case, the body is said to be in equilibrium. We have different kinds of equilibrium that you are always aware of, right? Yes. Next, state the condition when a body is in static, dynamic equilibrium. Give one example each of static and dynamic equilibrium. So we have explained this in depth about static and dynamic equilibrium. Okay, before answering this question, go back to the video, watch the video, and then come back to this. It's already uploaded in the playlist. When a body remains in a state of rest under the influence of applied forces, the body is said to be in static equilibrium. This is a definition of static equilibrium, and also it is a condition as well. Both definition and the conditions holds the same, right? For an example, a book lying on a table is an example of static equilibrium, right? So it's lying on the table. There is no change in the state of the book. So it is in a static equilibrium. When a body remains in a state of motion, whether let it be translation or rotational, anything, let it be, under the influence of applied force, the body is said to be in dynamic equilibrium. So if it continues in the state of motion, then it is said to be in dynamic equilibrium. Example, raindrop reaches the earth when the constant velocity is in dynamic equilibrium. This is an example of dynamic equilibrium. So other examples are given while doing the lesson. Go back to the playlist, watch it, and then come back to this. Yes. Hope you have understood all the concepts, all the questions which were taught in this video. Usually there were some 5 to 6 questions taught in this video. Hope you have understood them and hope you have liked the video. Please click on the thumbs up button if you have liked the video. Please do share this video and comment on this video if you have any doubt, any suggestions or any concepts to be clarified. You can mail me using the mail ID studywithakshay65@gmail.com. It is also in the discussion section of my YouTube channel. Right. So before ending this session, please do wear dual mask, follow social distancing, Sanitize at regular intervals. Together, let's all fight against this COVID-19 virus. Stay home, stay safe. Let's meet with the next video. Thank you.